How are you guys? Welcome back to my channel. So on this particular tutorial, we're going to be doing assembly drawing, right? This is also part of engineering drawing. So what is assembly drawing basically? Assembly drawing is like you're given certain parts, right? Then you're asked to assemble them. Let's say you're given a car wheel with the nuts, like it's dismantled from the car. Then you're asked to assemble it to that car, right? So if they ask you that, you have to know what type of wheel you're dealing with. So now let's just try to see what they are asking us here. So as you can see, we have our objects that want to be assembled, right? So what we do here is you first have to identify the parts that you have. So as you can see, for this one we have 1, 2, 3, 4, 5, 6, 7. I think we have 7 parts that want to be assembled to form a unit, right? So right now I'm just writing for you like what each part is and how many are they, like what do they do, right? So that one, that's a head screw, right? Everyone knows a screw. That one's cylindrical. So a screw, it just means it's going to be used to fasten, right? That's what it's going to be used for. Then for a washer, what we know for a washer is is there so that the bolt or the nut doesn't have direct contact with the object that we are going to be fastening on, right? That's the point of the washer. That's the use of the washer, right? So now what we have is another bolt. That one is a smaller bolt. It was written M12. Then there's that nut there. Then there's that base, right? So now the trick in assembly drawing, let's say for this one, we're not given a statement saying that you should assemble this to that, this to that. What you do is you have to look at the dimensions that you are given. There are certain holes that correspond to some screws. There are certain holes that correspond to certain parts, right? So now let's go ahead and draw. I want to show you which elements correspond to which elements, right? As you can see with that through hole, right? That through hole, if you see, it was written 12. I think it was written diameter 12, right? And on that part, on that top part, as you can see, it says a hole that is 12, that is a diameter of 12 millimeters as well. So now what you start thinking is, do these correspond? If you see that they correspond, where do they correspond? On the 12 millimeter, right? And what you want to ask yourself is, if I join these, how are they going to be fastened? How are they going to stay in place? Then we found that on that right hand side, there's that board written M12, right? So now you go ahead and say, oh, so there's that board written M12, and there is that through from that support. I think that one was written supports, and then the other one was written I think it's base. I don't know what was written there, right? So now what you see is those are corresponding, right? So now, as you can see, that one was a pulley. I think it was a pulley. What does a pulley do? A pulley has to go around, right? So a pulley is supposed to be in between something. I don't know if you still remember in your physics classes. A pulley was in between something, right? So now what you see is, okay, those two supports, what are they supporting? You ask yourself that because they are written supports. You ask yourself, what are they supporting? Now you see, okay, there's a pulley, right? So it means that the pulley is going in between and it's supported by those two, right? And now what you see is between those two, like the vertical part that's going upwards, it is a it has a diameter of was it 24? was it 24 or 16, 18? I'm not sure. I think it was diameter 18, right? So now what you see is, okay, our pulley has also another through hole, which is 18. So now what you start asking yourself is, okay, so these things, they correspond, right? You get what I'm saying? If you see that they correspond, what it means is that it goes in between those, right? Now you also go ahead and ask yourself, if you put this in between the supports, if you put the pulley in between the supports, right, how is it going to be supported, right? You ask yourself, how is it going to be supported? After you ask yourself, how is it going to be supported? You see that there is that bigger bolt there on top that was written cylinder head screw, right? You see that one is a diameter of 16, right? And a length of was it 80 from the screw head to the part where we have another bolt coming, right? So now after you see all that, you now ask yourself, okay, how am I going to draw this, right? Then that's why I did that rough sketch over there. You see, I've tried to assemble all those parts, right? So now I'm just highlighting for you so that some of you can follow with me, right? I'd already written some. So let me write some of the stages for you. We have supports. What are they supporting, right? You go ahead and write to support the wheel. Oh, okay, it was the wheel, not the pulley. But still, a wheel is more like a pulley. It can also work as a pulley, right? It's in between something. A wheel, it should go round and round. But what's supporting it, right? So the wheel is supported by those supports, right? So now you go and say, how do you fasten it, right? There's that cylinder head screw. What is it going to be fastening? What is used in this situation? You see its dimensions. You see where could it fit, right? Because it's all about where something fits. That's how you know this one is going to be assembled on this particular part. That's basically engineering drawing, guys. So what you want to do is you want to have good imagination so that you can see which part is going to which part. That's just it. That's just all about engineering. That's all about assembly drawing and engineering drawing, right? So it's simple. I will tell you it's simple if you just get it from here. So as I'm highlighting for you those dimensions, I was highlighting where the nut is going to be. Now you see that part which was M12. There's that through hole which is also 12 millimeters. What it just means is that what was that? I think that was a screw. That was a bolt. That bolt goes through those two, fastening the base and fastening those two supports to that base. You get it? Okay. So for this one, I realized that it's a bit longer, so I won't be talking much of the time. You'll be at some point. I'll be playing background music so that where it is necessary, I would give you the hints. I would explain a little bit where we are going, how we are finishing it, right? So yeah, follow with me, follow through, and then you understand it, you get it with time, and trust me, this will work. Engineering, assembly drawing is something that's basic, is something that requires imagination, right? So now, since we have our sketch, we can now go ahead and do our measurements, right? So usually I love starting from the base going upwards, right? Because if you want to assemble something, it's wiser to start below, going upwards. Every house starts with a foundation going upwards. You can start with the roof, then you go downwards. That's not very practical, right? So I usually advise that you start with the base, going upwards. In whatever you do, be it isometric, start from the base, going upwards. Be it orthographic, start with your plan, then you develop other views. Everything you start, try to start with the base, right? Because the base gives you everything. Everything is going to land on the base. Everything is going to be supported by the base. That's our foundation, right? So right here, I tried to draw my base. So then I realized that I put it too far to the right. So I had to bring it back a little bit to the left side so that you guys can see. Because on my right side, there was not much light. So I wanted you guys to follow through. So now I'm just rubbing. So let's go ahead and put it a little bit to the left, right? And try to centralize it. Because one thing you also want to do in engineering drawing is you want to centralize your drawings. So I don't know if my pencil can be visible. I couldn't find that other one, which was a little bit darker. So I think went ahead and used that one. As you can see, I also missed that measurement at first. I took that was 202 instead of 220. It was written 220 on the paper. So I think you'd see me struggling if this was the correct measurement. Then yeah, don't be confused by that. That was a wrong measurement. I realized it later. Then I rubbed. So you should take 220 because your base was 220, right? Then you measure 220 and then you put it to the 220. So now I was trying to subtract 220 from 126 so that I see where those centers are, right? I've forgotten that you could just get the center of the 220, right? So now if you get the center of the 220, what you just do is you can just measure from that center. You divide 126 by 2. Then this side, this other half, you put that other measurement. And that other side, you put that measurement. Okay, so now let's go ahead and put our centers. So guys, if you were following, you can see that that measurement to the right wasn't the correct measurement, right? As I mentioned earlier, that I had made a mistake. So I realized it now that, no, there was a mistake somewhere here. That's why you see that I'm taking long to draw that line. So I was trying to fix that mistake so that I would have a correct measurement. So now, as you can see, I was trying to verify what measurement it is. Then I realized that it was 220 instead of 202. I put 202, which was a bit wrong. So now I have to go ahead and redo that measurement, right? So yeah, just follow through with me, guys. So now as you can see, I think you can see that we've now obtained our center lines that we wanted to obtain before. So now let's go ahead and mark those zones, which is going to be quite easier to follow where those rows are going to be, right, if we have those centers. So now you see that from that point to that center line, it's going to be 30 millimeters. So you go ahead and measure your 30 millimeters, right? Go ahead and measure your 30 millimeters. So now that you have your 30 millimeters, you project it vertical upwards, and later you have to measure 15 millimeters, because that was our height that we were given, right? So now you go ahead and draw your horizontal line where the 15 millimeter mark is going to be, right? Right, then that other side you also have to put 30 millimeters, right? Okay, so now as you can see, we now have our we have that base of our of those two support systems. So now we've been given that the distance of that our width or length of that thing was 80 millimeters. So now you go ahead and measure your 80 millimeters and see where that 80 millimeters is ending, right? Go ahead and measure your 80 millimeters from that side also. Okay, that's where our 80 millimeters was ending, right? So now you go ahead and project it vertical upwards, right? Project it vertical upwards, right? So now as you can see, we are now starting to have those vertical lines of our support system, right? Okay, so now what we want to do is we want to go ahead and measure the 15 millimeters of that part that is going vertical upwards, right? Exactly, that one, to make our support system, to see how our support system will be looking like, right? So now you have those vertical lines, right? You now want to get the height of the support system, right? So the support system, I don't have my question paper with me right now, so I'm recording this, but you just go ahead and check what was, but I think it was 80 millimeters as well, because it looked, I think it was 80 millimeters going up vertical upwards. So you go ahead and measure 80 millimeters. Now you have your height. So now as you can see, we now have our support system, right? So now we have a center line at 30 millimeters below the top part of our support system, right? So now let's go ahead and draw that center line. This is the center line that we are going to be using to construct our walls. That's the center line that's also going to be used to align the wheel, to align the nut and the cylinder screw head. That's also the center line. That's the same center line that we are going to be using. So now we have that one, right? So now as you can see, I was just measuring to see if our wheel will actually fit. Our wheel was 24 millimeters, right? And for me, I had 25 millimeters from that part to that part, so which means I was only millimeter away, which for me, I thought that was the thing, because if you wanted to add the washer in between, the washer was 3 millimeters. As you can see, it's actually now a bit bigger. So yeah, for me that was ideal. So I realized that our wheel is just going to be in that part alone, right? So now as you can see, I'm now measuring my wheel. So let's go ahead and measure that wheel, guys. From that side, you also need to measure 5 millimeters, because our wheel was 24 millimeters, then that middle section was 14 millimeters, right? So you go ahead and measure 5 millimeters this side, 5 millimeters this side, so that you have your wheel, right? So now as you can see, I was now just confirming if my measurements are correct, or how many millimeters am I short of, and is it really going to come out the way I had sketched it. So as for my drawing, it was coming out the way I had sketched it, and the measurements, the way aligning, I was just a millimeter short, so which was something I found not of any importance as such. So yeah, so now let's go ahead and complete our wheel that's in between our two support systems, right? So now, as you can see, I'm trying to show you how we are going to have that view, right? Okay, so now let's go ahead and measure the height of that view. So that view's diameter was 80 millimeters, which means our radius was 40. So from that center line, you measure 40 going upwards, and you measure 40 going downwards, right? I was just confirming where my 40 is going to end. I thought it's going to be ending inside that base that we had created, but then I realized no, that was just a construction line for our support system. So as you be drawing, you need to take note of your detail. You need to see how you're projecting. Yes, we make mistakes, but in an exam situation, I advise you to reduce those mistakes. That's why we are being given too much work at this time, so that you guys can practice daily, so that by the time you'll be writing your exams, you are now used to the thing, right? So now we are done with those measurements. What we want to do now is we want to go ahead and project our wheel, right? So then I was now trying to darken my wheel, because now I know that this is where the wheel is starting, this is where the wheel is ending, right? So that's our wheel, guys. That's in between there. I know at this point you actually can't see why I'm saying that we now have our wheel in between, but as I darken, you start to appreciate the wheel. You actually see the wheel and know where we are coming from and know where we are going. It's simple, guys, right? So yeah, I will show you how it's done and how you darken the drawing, right? So now, as you can see, I was now measuring the part that's going downwards. I think its radius was 60 millimeters. I'm not sure, I can't remember, right? So now I was measuring, I measured 30 upwards and 30 going downwards, right? So no, that was a measurement for that washer. So our washers, our washer was it 3 millimeters? It was 3 millimeters, right? So now I'm measuring that 3 millimeters of that washer. Exactly, as you can see, the 3 millimeters of our washer. Because washers, as you can see, I think what I want you to notice is that on that washer it was written 2 off. 2 off just means they want 2 washers, right? 2 washers are required, right? That's the meaning of off in this situation. You can also see another question saying 2 REQD, right? 2 REQD. There's a question that was saying that the REQD in engineering drawing means required, right? So you can see it that way. So it means that they wanted 2 washers. So the washers, you put them to the right hand side and to the left hand side, right? So that our washer, there won't be direct contact between that cylinder head and that bolt to the support system. There's a washer that is going to support that, right? So yeah, let's go ahead and add our washer, right? So we added our washers. So now what we want to do is we want to go ahead and darken our diagram as for now, so that you guys start appreciating where we are coming from and where we are going. So as I'm darkening, you realize that I'm not considering any sectional view. The reason why I did this is because the question didn't specify whether it wanted a sectional view or just for you to show the assembled drawing of the views, right? Of the views. So I did this so that you guys will see what this thing looks like before we section it, so that you guys won't have confusion. But I will also make another video where we will now section this thing, right? Like, we will assume that if we cut this thing at this particular point, how is it going to look like? That's what we call a sectional view, right? So a sectional view is like you're imagining that you cut something in half or something at a certain point, right? You remove this other part. How do you visualize that thing, right? So to show this on paper, yes, the shape might be just the same because most of the things, they are symmetrical, right? So what you do is, where you have cut, you draw what we call sectional lines. These sectional lines, they can be usually they are at an angle of 45 degrees, right? So you draw your sectional lines. So we'll make another video for you guys to understand and appreciate these concepts. Because for now, what I just wanted you to know is, how do you assemble these things? How do you visualize it? How do you come up with one unit, right, when asked to assemble these things? So now, as you can see, we are now darkening our part. Do you see the wheel that I was talking about? That's in between, right? That's our wheel there. So now we have to consider that diameter, which was 60, I think. So you go ahead and measure your 30 going upwards, and you measure your 30 going downwards, right? So it was 30 there, and then you want to measure again another 30 going downwards, right? So now you go ahead and darken that part. That part is part of our wheel, right? Because that height, we got it from that wheel, right? So now you also go ahead and measure your 30 going downwards. So now, as you can see, that middle part, if you can actually visualize that wheel that we're given on our question paper, do you see that they just look the same? If you can notice that, guys, then you are following with me. That's our wheel, guys. That's just basically it, right? That's our wheel right there, right? So now what I'm doing here is, I want to darken the washer that we are given. So that's how you draw a washer, guys. Mostly washers, to show a washer, you don't just draw it in a cylindrical, like just a rectangle, right? No, that's not how you visualize a washer. A washer is that part which looks like it's more of like inclined, or it's at an angle. So that's how you show a washer. Then you go ahead and complete that part, right? So that your washer comes out. I don't know if you can actually see how my washer came out, right? So now I was just projecting those points back to that other part of the washer, so that you guys can follow through as we darken that other part of the washer, right? So now let's go ahead and drop that. That line is for our support system. I don't know if you have noticed it. And then that line that I'm drawing there is for the washer, right? So now I went ahead and projected those lines so that we know where we are starting from for our washer. Because our washer, we say that there's a part that's more like an incline, right? That's how you show a washer. Though a washer might, in real life, might look like it's more of like just something that's circular, right? But that's how you show a washer, guys. So let's go ahead and draw our washer, right? I don't think it's that visible. I'll make another video. On the other video that I'm going to be making, I will show you how a washer looks like, or you can just go ahead and Google it, how to show a washer in assembly drawing, how to show a washer in engineering drawing. Just Google it, so that by the time you draw the washer, if it's not visible on this video, you can actually visualize it, how it looks like, and appreciate it, and so that you won't get confused. Because what we want to do is engineering drawing is quite simple. It's not about talent, it's about the concept. The concepts, you need to master the concepts, keep them, and just meditate them, right? Because what you want to do is you want to master the concepts, then you just do one example. If you know the concepts, if you just do one example, everything comes back. Because there's a point that I forget some things. Like on this one, I had forgotten some things, but by the time I just look at the thing, I start, okay, this goes here, I'm doing my sketch. By the time I'm done with that, everything about assembly drawing comes back. Bring me any assembly drawing now, I will tell you that I can do it. Why? Because I had the concept, I know the concepts. Then if you just forget one concept, by the time you're assembling this, you know, okay, this is how you do this. So try by all means to master the concepts. You don't cram drawing. Drawing is practical. It's something you live with every day, right? So let's go ahead and darken our item. So as you can see, we have darkened our base. Then as you can see, those are our support systems that are going from the base going upwards, and our wheel in between. Can you see, guys? This is actually fun. It's fun doing these things, like seeing it come out the way you wanted it to, and seeing it come out the way it is supposed to. So that's the nice thing about engineering drawing, about assembly drawing. The thing will come out. It will eventually come out. What you just want to do is you want to position yourself in a position where you imagine, right? You need to have an imagination. So now what I wanted to do was to draw our cylinder head, right? Our cylinder head, it was what was the height of our cylinder? I think it was 24. I think, yeah, it had a diameter of 24. Our cylinder head. Our cylinder head is just that part of the cylinder, right? Of that cylinder screw, right? So now, as you can see, we are now projecting it, right? So now that was the height, right? So now our width was it was 12. It was 12 millimeters, if I'm not mistaken. So you want to go ahead and measure your 12, right? I written 12 there. You go ahead and measure your 12 millimeters. Then you put the width of that cylinder head. So let's go ahead, guys, and put the width of the cylinder head, right? Exactly. So now, as you can see, we now have our cylinder head. Do you now appreciate these things? You see, these things, they are practical, what I've been telling you. If you know the concepts, let's say in mechanical, car mechanics, blah blah, those things, you know, a boat, usually you need to put a washer. Why do we put a washer? If you know the reason why we put a washer, you know where the washer will go, right? So I want you to be practical when doing these things. If you just see this thing is written pulley, go back to physics. How did a pulley look like? How do you assemble a pulley? The concepts, they are just the same. If there's a question which was asking about a bush, how does a bush look like? Mostly bushes, they are rubbers found in cars, right? Most people, they might not know them, but yeah, you know rubber bushes. How do they look like? How can you assemble a rubber bush, right? So start appreciating these things. Be practical when doing these things, right? Let's be practical. You get these concepts, guys. It's very simple, very easy to do. Trust me, by the time we write exams, the time we do the many tutorials, many examples, you guys would have mastered these things, right? So now what you want to do is you want to go ahead and draw that nut that was going to fasten our wheel, right? We want to draw it to the right side, right? For me, my cylinder head screw is moving from the left side through that hole to the right hand side, right? So as you can see, our through hole, that one had no threads. What do we call threads? If you have seen a bolt and a nut, where you screw the nut is those are what we call threads. Those things that make our hole tighten, our screw tighten. Sorry, those are what we call the threads. I think you know threads, guys. So our hole, our through hole in between the support systems, the wheel itself, they had no threads, which means that our cylinder screw head was just going to slide in, right? It was just going to slide in, and our threads, you now find them where the nut is going to come in. So now that's where we are drawing, right? As you can see, that's where we are drawing. So as I have said before, this is not a section of you guys. This is just how you see the thing without cutting it, just assembling it, right? It's just like how a car is being built. After putting all the wheels and stuff and everything, you just see the car as it is, right? You don't see the inside of the car, right? But if you now cut the car, that's when you can actually see, okay, there are seats inside, there are what. But if you don't cut the car at any given point, you just see the car, you just see the outside faces, the doors and stuff only. So this is what we are doing. We are assembling our drawing, right? Let's say it's a car, we are putting the wheels, we are putting the mirrors, the glasses and everything. After having that, you can now say we now have a Toyota GD6, we now have a Mercedes, we now have this car, right? Why? Because we have assembled certain parts to come up with a certain shape, and then that shape that you see outside is what you say, oh, now this is a Mercedes. Then if you cut that through that, which we call the section of view, that's when you can actually say, okay, if you cut this car enough, you start seeing the seats inside, the what, because you've opened through, you've divided the car into two parts. So that's what section of view is. I'll keep on explaining this so that by the time you watch the other video, you try to relate with this one, you actually start appreciating the concepts as we go, right? So now I'm now trying to draw my boat, that other side, right? So for this boat, I realized that it was directly coming at the end of that cylinder screw head. So now what I did was I just tried to take that distance so that you guys can actually see. I tried to draw it as big as it is. But what I will do is I will make another video teaching you how to draw boats, right? Because I couldn't explain it on this video. I used the concept that I mastered myself, but I couldn't explain it because this item was a little bit smaller. So I'll use a whiteboard also and a marker to show you guys how do you construct a boat, how do you construct a nut, how do you draw it, how do you construct the curves, as you can see. So now I just tried to make it bigger. I didn't pay attention to the dimensions, so I will make a video showing you how do you get the dimensions before you get into the exam or before you submit the assignment. So yeah, just follow through. As you can see, that was our nut, right? That's our nut there. So let's go ahead and complete that nut. I tried showing you how a nut might look like, how you might construct it, right? Where the curves would touch, how it might look like. So that was just a simple construction I was trying to show you. That's how a nut will look like, right? So now let's go ahead and complete it. now as you can see, we're done with that bigger nut, right? As I had mentioned earlier that this video was a little bit longer, so I wasn't going to be doing much talking. Sometimes you should just follow through the steps, right? So now we want to go and draw that the last two nuts that we have. The last two, those ones are bolts. A bolt is one that has threads from where the ceiling, from where the head is ending to the last part of the bolt. That's what we call a bolt. So there's a bolt and nut, right? So a nut is just something that screws onto the bolt. A bolt can screw itself to a certain part, right? So a bolt has threads, right? A nut only has threads that are going to be that are going to be going somewhere. So to master this, what you want to know is that a nut is it's called a female bolt. Why? Because it is going to be entered by something, right? That's why it is called a female bolt. Then that cylinder head, let me give an example of that cylinder. It's called a male bolt. Why? Because it is the one that's going to enter somewhere, right? Where is it going to enter? Into our female bolt, right? So that's basically it. So now I was calculating the height of that bolt. That was just the formula. The formula to get the height, that height, it's m multiplied by 0.7. M, if you see, we had that written m12. So what you do is you say m times 0.7 to get the height of your bolt, right? So we've done that, right? Now we got our m, right? If you have your m, you say m multiplied by 0.7, you now get your height. You have your height, right? That's what we exactly did. So yeah, as I had mentioned earlier that on that one I didn't pay attention to that, right? I didn't pay to m times 0.7. Why? Because I wanted you guys to see, right, and appreciate it. But what you want to do is on that one, on that big one, you also want to go ahead and say m times 0.7, so that you get your height, you get how big that bolt was, right? So yeah, let's go ahead, guys, and draw that one. So now as you can see, that's the head of our boat, right? Now we are trying to construct the head of our boat. So let's go ahead and do that, guys. now we are almost done with our drawing, guys. Thank you so much for tuning in to this tutorial. Please don't forget to subscribe, like, and share the videos with your colleagues. And guys, I'll make other videos bringing you new examples, not the ones that are just in the assignments, bring you new examples that will make you appreciate the concepts. So thank you guys for tuning in. Have a blessed day.